So lean is all about identification and elimination of waste. Thereby, you are transforming your process from its current state to a future state. The advantage is the future state process will be very simple, right? And the simple in the sense.
I know I got your this thing WhatsApp.
Simple in the sense it will have only fewer number of activities, and all of them or most of them will be value adding. Very few of them will also be non-value adding. You know why still non-value adding exists? Because certain non-value adding activity we just cannot eliminate. For example, consider our training program. We started by 9:30 and now it is 4:30. And do you find every single minute we spent so far is really productive? Productive in the sense you are able to learn some new things every single minute?
Yeah.
If it is yes, then all the activity carried out in the training program are value adding. If it is value adding, that means it satisfies your customer. It again means we should do more of it. But coming to the lunch session, 1:15 to 2:15, is there any learning happened?
No.
No.
So what is that activity? Value adding or non-value adding?
Non-value adding.
But tell me, can I
Essential,
eliminate that?
essential non-value added.
Yeah,
Essential non-value added.
It is definitely non-value adding from the learning point of view. But can I eliminate that?
No.
If I eliminate that, what will happen? It will affect the post-lunch session, isn't it? So there are certain activity which which becomes a kind of process requirement or a business requirement. You can't eliminate completely.
Part and parcel of the activity.
Yeah, exactly. So you must consider reducing such activity, not eliminating. Keep lunch, but don't give 1 hour. Give only half an hour. Tomorrow probably we'll try that, right? So instead of 1 hour, we'll make it 30 minutes. Similarly, lunch instead of break 15 minutes, we can make it 10 minutes. We can try. These are all the ways by which we can actually improve, right? But what needs to be done to reduce the lunch to 30 minutes and tea break to 10 minutes, that we should be ready for that. Otherwise, by doing that changes, the output might suffer. So lean is all about identification and elimination of waste. In my opinion, it is nothing but simplification, process simplification. And another simple explanation for lean, if a better way of doing a work exists, if you don't adopt it, then what you are currently doing is a waste. How many of you understand this explanation? If a better way of doing a work exists, but still you don't adopt it, then also what you are currently doing is a waste. Why? Because if you don't understand, if you don't change, your competitor will understand, will make the change, and then will beat the competition in the market. So that should not happen. For example, consider the banking operation. 10 years before, how the banking operations were carried out and how the same operations are getting carried out. Even to avail a housing loan, you don't have to walk to the bank. Isn't it? How drastically the process has changed. So many steps are eliminated, which they didn't know earlier, but today they know. And for example, I want to withdraw money and then pay rent to my house owner, flat owner. 10 years before, I have to go to the bank physically, withdraw the money, and then count it, bring it back, and pay to the flat owner. But now, how are we paying the rent? We just open GPay or a mobile app, press 3-4 buttons, and now the payment is done. What happened to all the steps which we did earlier? Going to the bank, filling up the challan, standing in the queue, collecting the money, and then coming back and paying to the flat owner. All the steps are removed, but purpose is solved.
Process improvement.
Process is simplified. This thinking is called lean thinking, right? You should be able to understand each and every step in your process. We call it activity, and ask yourself 3 questions. First question: for doing this particular step, is my customer willing to pay? If my customer is willing to pay, then what I am doing is value adding. If my customer is not willing to pay, then what I am doing is a non-value adding. I must consider eliminating such activities. Just because my company is doing last 10 years, you should not continue doing that. Ask yourself these kind of questions. By doing, for example, I keep an inventory. I have a big warehouse and then where tons of raw material, tons of finished product I store. And tell me, can I charge my customer, for storing all the material in the warehouse?
No.
Customer is not bothered about whether you have a warehouse or not, isn't it? Whether you have a warehouse or you don't have a warehouse, customer is least bothered. He can't even pay you single rupee because you store the material for years together. No. So keeping a warehouse and storing all the material in the warehouse is actually a waste from the customer's perspective. But it is required. Why it is required? Right now your process capabilities are weak. You have to have a lot of inventory. Why you have a lot of inventory? Because my sales team is not forecasting the sales properly demand. So I have to keep a lot of inventory. So for certain reasons we keep, but waste is a waste. Understand? Second question, whatever activity I am doing, is it really transforming my product from the current state towards the final state? If the answer is yes, then what you are doing is value adding. So far we did 4 or 5 sessions, 4 sessions. Is that every session is moving you from your current state towards your green belt or black belt? If the answer is yes, then the sessions are required. Suppose if there is a session where you are really not able to understand whether you are progressing towards your goal or not, then that session we must consider eliminating because it is non-value adding. For example, I talk something which is completely irrelevant to Six Sigma or Lean. That session may be great, but it is useless from the customer point of view, right? Second question also understood. And now the third question is that the activity is done correct at the first time. Is that the activity done or right at the first time? Or if you don't do it right at the first time, what happens? You rework. You produce defects and then correct. So if the answer to all the 3 questions is yes, whatever you are currently doing is actually value adding. You can continue doing that. If answer to one of the question is no, then what you are currently doing is non-value adding. In plain English, what you are doing is a wasteful activity. The word waste may be painful to some of you because you have been doing this for several years together, but Lean calls it as waste. We should be able to understand what is waste and what is useful activity, right? And this thinking and this perspective will give you an additional eye to understand lot of improvement opportunities. This additional eye will help you to bring all the problems to the surface. Otherwise, what happen? All the problems will be hidden, in your workplace, and people will never be able to solve, right? And this is what I highlighted with this example, right? The traffic environment, you can continue enjoying your driving in the traffic environment, or you can decide to change the environment completely. With the same car, with the same driver, you can perform, you can produce better result without even changing your existing setup and existing employees. All of you can make your company perform at least produce double the result by applying Lean principles. And it is very, very easy to implement Lean. All that required is a mindset to accept the change, a mindset to call waste as waste, right? So these are the several tools which one must know to become an expert in implementing the Lean. 7 waste, 5S, workplace organizing tool, Kaizen, SMED, single minute exchange of dice, Kanban, a kind of full system, right? And VSM means value stream mapping, TPM, total productive maintenance, how to take care of the maintenance so that maintenance never becomes a reason for the quality issue. Maintenance never become a reason for the quality issue. That is called total productive maintenance. And 3M simply stands for Muda, Mura, and Muri. All of them are Japanese word. Muda means waste, the non-value adding activity, right? Mura means unevenness. I already told you, you have to level the workload, right? You have to balance any production line, any manufacturing line. You must balance it, isn't it? These are all, aiming for Mura, right? Aiming for minimization of Mura. And then Muri means overburden. if you don't load the resources evenly, then what will happen? It will lead to overburdening a resource. It will lead to overburdening a resource. For example, today there are 3 trainers spoke to you. Myself, Dr. RK, and then Ravi. Now the advantage is, all of us can maintain our energy level. Suppose if I conduct all the sessions, right, without involving Ravi and Dr. RK, what happens? Probably first 1 hour I can do well, and then the same trainer, which actually able to keep the energy level high, will eventually will drop, isn't it? So the same thing can happen. This is because you have overburdened the resource. So that is called Muri. So our goal is to eliminate the Mura as well as the Muri. If elimination is not possible, what we do, we'll at least reduce them, right? So these are the 4 guiding principles which we talked about in the morning. These are the 2 pillars of TPS. This question also we discussed already. And of course, origin of Six Sigma. Yeah, we understood thoroughly about how the birth of the lean. And since the lean evolved, the Japanese started dominating in the global market, right? So somewhere around 1970s, the Japanese focus upon quality had superseded Americans. The Americans started feeling that their quality levels is stinking, and particularly a company called Motorola, they started worrying about it because they could sense their market share gradually going down, and so they wanted to resolve the issue. And so in 1987, Bill Smith, who is today called the father of Six Sigma, he is a engineer like all of you, and Dr. Michael Harry, who is a statistician. These 2, under the guidance of the CEO of the company, Robert Bob Galvin, they developed an approach called Six Sigma, by which they were able to make their business processes produce defect-free outputs. I said business process. That means, it is applicable to any business, not only manufacturing. Though initially it was applied in manufacturing, even right at the time of inception, projects were run in the non-manufacturing segment also. Be it accounts, billing, purchase, marketing, warehouse, whether it is your value chain or your supply chain, you can comfortably, improve your business process using Six Sigma methodology. And they also followed a specific 5-phase methodology called DMAC to resolve all existing failures. That means it's a corrective action. And the same approach can also be used to prevent the problems, right? Because Six Sigma is all about defect prevention. And for the best practices they maintained in manufacturing, in 1988, Motorola was awarded the Malcolm Baldrige National Quality Award. And 1989, Six Sigma became a flagship approach to quality. And every company, wanted to learn and implement it. Companies like Xerox, General Electric, Kodak, to name the company, name any big brand, they will talk about Six Sigma without any doubt. If some of you are seriously interested in working in such, work for such bigger brands, then you have to be a certified expert in Six Sigma. Otherwise, you just can't enter their campus, because for them Six Sigma is a culture there. They do even a small projects, they do it systematically. And so you have to be a belt holder in Six Sigma body of knowledge, and to enter into the company as well as move ahead in the career ladder. And it is the company General Electric, somewhere exactly in 1995, they adopted Six Sigma in all their areas, and they realized that adding one more phase is important, because when Bill Smith and Michael Harry introduced, they introduced as 4-phase methodology, MAC. They started with only measure. That time D was not there, but only in 1995, MAC has become DMAC, right? Because defining the problem is more important before measuring. So they added the D, and that's how the DMAC methodology has become very popular. And nowadays Six Sigma skills are in great demand in all industries. So this is again a small story about Motorola. And that time they were having a division which was manufacturing televisions, right, in the brand name called Accuser. And they were not able to really do very well in terms of quality. And there were a lot of warranty claims. We all know warranty claim is a kind of external failure. Why external failure is happening? Because they were not able to detect the failures internally, and so customers are detecting. And why they were not able to detect the internal failure? Because they don't have proper process and system. So as a result, their they were really not able to achieve profit, and they have decided to sell the brand completely. So they sold the brand, and a Japanese firm took over this brand, and then they made the same brand successful. And this made the executives at Motorola think about what went wrong, right? Because the brand which they were not able to make it popular and make it successful, some company from Japan, it's called Matsushita Electric. That company, they took over this brand and made the same Accuser very popular in the market, and today it is called Panasonic, right? And this is the the company which purchased. So this made the CEO of the Motorola to think deeper, Robert Bob Galvin, and he told his executive and exactly this statement: I do not know what you will be doing. We have to see to that our company achieves a 10-fold growth in the next 5 years. And the responsibilities were given to Bill Smith and Dr. Michael Harry. Bill Smith is engineer, Michael Harry is statistician. This combination really worked well for Motorola and made Motorola achieve fantastic results, and leading to few $billion savings, and achieving a Malcolm Baldrige Award and all those things. And the underlying concept behind the idea of Bill Smith and Michael Harry is statistics, a specific distribution called normal distribution, theory of normal distribution. We are going to teach you, and you must have patience to listen to us and then understand what this normal distribution is, right? And which was introduced by this German mathematician called Frederick Gauss. They used the theory of normal distribution and developed a statistic-based, metric-based system for Motorola, by which they systematically detected and solved all the problems, right? And made all their critical processes, business processes, defect-free. And they named the methodology as Six Sigma. They named the methodology as Six Sigma, approach as Six Sigma. And in order to resolve the existing failure, they developed a methodology to approach the problem and fix it at the root level. And that is the MAC methodology. And look at the savings they made in just 10 years, $16 billion. And it is the year 1988. They received Malcolm Baldrige Award. And today we call this gentleman as father of Six Sigma. And it is this person, Dr. Michael Harry. He popularized Six Sigma. Maybe now every company, started adopting Six Sigma. All the guidelines about the belt level, body of knowledge, and everything was developed by Dr. Michael Harry, and the university was created. And now we are also just following the Motorola. So what is basically Six Sigma? Six Sigma is a management philosophy to meet business objective by reducing process variation. So variation is the root cause of all problem. If there is no variation, what does it mean? Your results are consistent. Your results are consistent, isn't it? If your results are consistent, you exactly understand what is happening. If your results are not consistent, then making a conclusion itself will be a big problem. And so according to the Six Sigma philosophy, variation is the root cause of the problem. Imagine you are manufacturing some product in which the dimension is important. Let's say the dimensional requirement is 100 plus or minus 0.5. 100 plus or minus 0.5 is the requirement. So customer can accept your product if the dimension goes up to 100.5 on the right side, 99.5 on the left side. These are called specification limit. You can see them here, LSL, USL. Now I want to know how good my business process is. So I go to the process, select some sample and measure the dimension. What is the goal of the process? To produce products with the dimension of 100. Is it happening or not? I now took sample. Now let us say I took 100 sample. Do you think all 100 sample will have the same dimension? Variation is the rule of the game, is the rule of the nature. You just cannot avoid. We think every day we have 24 hours, but actually not. We think every year we get 365 days, but actually not. Isn't it? So variation is the rule of the game. You can't avoid. All 100 units will have a unique dimension. Then how do you know whether your process is capable or not? You have to measure two things. One is the central tendency of your data. Another thing is the variation of your data. What is central tendency? The average value. That is what you are seeing here in the center. A center line. The center line should be inside the specification limit. Am I correct? If center line itself is not inside the specification limit, it simply means your process is operating in the wrong place. It is completely unfit to produce quality product. So central tendency is giving a clue. But in both the diagram, if you look at, the central tendency is perfectly in the midpoint between USL and LSL. It doesn't mean that all your products are on the target. No, we already know that each product has unique value. So in addition to the central tendency, I want you to calculate one more parameter to measure the variation in the data. Variation can be measured in several ways. The simple way is measure the range. Do you know what is range? The highest value. Am I boring?
Lowest value.
The highest value minus the lowest value. If the range is too high, it simply means your process is wider. Am I right? If the range is too less, it simply means the process is narrower. Look at the process, two processes I am showing here. First process is too wider. The second process is too narrower. Which one can give you better products for the same central tendency?
Which is narrower.
Narrower, right?
Narrower.
So any measure of variation should be too low to produce quality product. And any measure of central tendency should be on the target. So 100 will be here. See here 100. This is 99.5. This is 100.5. And if your range calculated comfortably falls within the LSL and USL, then all the products you are manufacturing will now be accepted by the customer. But if the range is too wide, what happens? Your process will go beyond the specification limit. That is what you are seeing here. Don't worry, we will again come to this point and then understand deeper here. So as that means just by looking at two parameters from the data collected from the process, one is central tendency, another one is variation. By looking at these two parameters, you judge on the capability of the process to produce quality products. If the capability is too high, let's say 6 sigma level, then you are sure that your process will produce defect-free outputs. No defects, absolutely no defects, and so no wastage, no rework. Your cost will be reduced and your results will be consistent. Since your results are consistent, the process becomes predictable. What is going to happen tomorrow? What is going to happen next week? What is going to happen after 6 months? Since your process is so consistent, whatever happening this month, the same thing will happen next month also. But how do you know the consistency? By looking at the measure of the variation. It could be either range, or it could be standard deviation, or it could be variation, right? Variance. As a result, your customers and all the stakeholders will be happy. So this is the philosophy behind Six Sigma. So what we do, a real-time problem, a practical problem is converted into a statistical problem. We see the problem through numbers. What are those numbers? Either the central tendency or the measure of the variation. If I control the central tendency, control the variation, my real problem will get solved, right? This is the Six Sigma methodology. And these were a few other reasons. Probably I'll discuss with you a little later. Yeah, maybe this is very important. So Motorola, they made so much savings in manufacturing. See here in non-manufacturing itself, they made a $1 billion saving. Similarly, ABB, again, they are the Swiss-based heavy electrical equipment manufacturers. and they made 68% reduction in the defect level with 30% reduction in the production cost and with $898 million saving each year. Similarly, General Electric, by spending $500 million, because Six Sigma is little costlier. You have to train your people, produce green belts, black belts, and then only know they can drive the projects towards success. And they were able to get back $2 billion in just 1 year and $12 billion in the next 5 years, right? And all of these become inspiration to other companies. And now you name the company, which is a good brand, and they will talk about Six Sigma and they will practice Six Sigma. So Six Sigma is fundamentally an operational excellence model, an aggressive campaign to boost profitability, increase market share, and improve customer satisfaction using quality as the strategic business focus. And it is, as I already told, achieving operational excellence is a monumental task. Everyone in the organization should be involved, and committed people should lead the drive, right? And benefit is customer satisfaction, cost reduction, and as a result, legal compliance and everything, falls in line. So Six Sigma is essentially a metric. It tells you how capable you are, how good your process is in meeting the customer requirement. If the Sigma level, if the capability is high, Sigma level will be high. If the Sigma level becomes 6, almost, the defect rate is close to 0. If at all there are any defects, you are sure that it is limited to just 3.4 DPMO. DPMO stands for defects per million opportunities. Six Sigma is also a methodology. It prevents problem. If there is a problem, it solves the problem by, advocating a methodical approach, which is called DMAC. And Six Sigma is a way of management. Company who understood Six Sigma and practicing Six Sigma, they connect the career progress and the belt level. Obviously, people have to equip themselves, fit enough to contribute to the organization's growth. Then only they can grow in the career ladder. Otherwise, they have to stay in the same level. And Six Sigma is also a philosophy. If you thoroughly understand all that what we have discussed, all of you can apply in your workplace. Some of you may be manufacturing, and some of you may be into service. Some of you may be into calibration. Yes, whatever we discussed, all of them are applicable, to each one of you. In that sense, Six Sigma is a philosophy. It's a metric. You are sure that the defects are limited to 3.4 DPMO. Methodology, broadly, there are two methodology. One is to fix problems with the current products. Another one is to develop new products without any defect. It is, curing a disease. It is giving birth to a child without any disease, right? One is for improving existing product. Other one is for developing new product. If we use Six Sigma ideology to develop new product using the methodology called DMADV, your approach is called Design for Six Sigma. Your approach is called DFSS, right? And these are the belt levels, and it is applied across all levels. And to quickly, what is define? So define, measure, analyze, improve, and then control. What is define? You are making the problem measurable. You are expressing the pain experienced by the internal customer, experienced by the external customer, or experienced by the business leader in using a number. Using a number, using a metric. What is that called? CTQ. You are identifying a CTQ. For example, we discussed, I want to live longer. That means I want to be healthier. That is my bigger why. Now the drivers of satisfaction. Drivers of satisfaction means smaller whys. What are smaller whys? My body BMI, my fasting blood sugar, my 3 months average sugar level, the HDL value, LDL value. But again, HDL value, LDL value, I can't fix easily. I have to control my lifestyle. I have to control my food consumption. I have to control my, exercising activities. Those are X variables to control these Y variable. But when I can control all these Y variable, I can lead a healthy lifestyle, and I can actually live longer, right? So expressing your goal, expressing your problem in the form of a number is the key towards attaining the result, right? So define is nothing but making the problem measurable and then actionable. Once the problem becomes measurable, you proceed with the measure. This is what every medical doctor is doing. You go to a doctor, you express, you will narrate all your problem. If the doctor asks you, yes, tell me what's your problem, then we just cry in front of the doctor, right? With all our problem. But do you think the doctor will immediately take action? No. He will try to figure out the specific statements from you. Once the specific statements makes the doctor really understand the problem, then only he will proceed with the treatment. Again, even if you understand the problem, he don't directly jump to the solution. He will ask you to do some diagnosis. That means what the doctor is doing after defining the problem, doctor is also going to the measure. Same way, you should also, even if with all the information, even if you understand the problem specifically, still you have to verify the problem with the data. Like the doctor is doing diagnosis, you should also go for a collection of data. And now the problem with the data is, every time you collect the data always comes with the error. Either people don't give right information, or they don't know how to get the right information. So there are two types of error is always possible. One is measurement error, another one is sampling error. If you don't know how to measure, the error is called measurement error. If you don't know where from the data must be collected, that is called sampling error. So these two will make your data unworthy for any analysis. If the data is unworthy, you can't understand actually what is happening. For example, if you go to a diagnostic center where they have very poor systems and machines, will you go and give the testing done? None of us will go, isn't it? Because their readings will be false, and obviously the doctor will judge wrongly on our body condition. So measuring correctly is very important. Once you measure correctly, you get an idea about the baseline. What is baseline? Your current level of performance, your current body health, your current BMI, current HDL level. You get to know, but you are sure that that's a correct value, which is very important for proper progress. And now the baseline is understood, the target is set at the defined level, and so the gap in performance also understood. Now we proceed with the analyze phase to understand the reason for the gap in performance. And the reason for the gap in performance means this Y variable depends on several X variable. But as according to the Pareto, few of the X variable are responsible for the gap in performance. Those few of the X variable are called the critical factors, or called the root causes. And that criticality must be validated. Even if you know a particular individual as the criminal, in order to punish him, you have to prove the crime, isn't it? Then only the punishment can be given. Similarly, in order to make the changes, you have to validate the root cause statistically. If validation is done, you can now move on and start talking about the solution. Why I am asking you to now start talking about the solution? Because you have defined the problem. You measured the problem. You analyzed the problem and understood as well as validated the root cause. Now you are really in a commanding position to talk about the solution, right? There are certain tools by which you can actually provide. See here, I'm using the word treatment. Doctor gives treatment. Similarly, you are also going to give treatment, which means you are offering a solution. What is solution? You are going to optimize this X factor. Optimize this X factor. And now that problem is solved. Now what the doctor will do? Doctor will give you a lot of advice. So you drink more water, do some exercise, and eat healthy food. What is this? The doctor is giving you a control measure, isn't it? The doctor want to see you living healthier longer. Same way, you have solved the problem. Can you help your organization sustain the benefits of the results for a longer period? For that, you have to continuously monitor and control the critical factor. You know why? It is the critical factor which caused the problem. If you don't allow the critical factor again to deteriorate, the same problem cannot come. So this is what we will be doing in control measure. Now tell me, do you think all these 5 phases are important? Define, measure, analyze, improve, and control. I can't remove any of them, right? And what we made it in this training program is, we have broken down each phase into 3 simple steps. And so the whole training program, whole learning process is going through 15 simple steps by which you systematically eliminate the defects and waste from any business process, to produce defect-free outputs. So these are the 15 steps which you will gradually learn. Already we discussed about first step, which is project identification. The second step, project selection. But project selection, we'll discuss one more tool. But right now, what we discussed is Pareto. Pareto helps in stratifying the problem. Pareto helps in prioritizing the problem. But we have one more tool called project prioritization metrics. And then we create a complete plan of execution for the project. What we call it as project charter. It is the project charter that must be approved by the top management for the project to come live. So once your project charter is approved, your define phase is over. You can actually proceed to the measure phase, and all that we will be discussing one after the other as we go through the program. And these are all the tools you need to master to really do well in every phase. If you do well in every phase, the results will definitely obviously be great. And every phase there are 3 steps. What is that step? What is the expected outcome? What kind of tools and techniques you must use? If you master, then there will be outcomes attained properly at every step, and so every phase will be successful. You can go through the toll gate review, and your project result will obviously be as expected. And these are the tools, and don't worry, we will be going through them as we progress in the program, but some of them will be required at the green belt level, and most of them will be required at the black belt level. So these are the different levels. What is white belt? I'm sure by now all of you have already become white belt. Your skin color has slightly changed now already, right? You know how important it is to look from the customer's perspective. You also understood how important it is to have a process-centric approach. You also have understood how important it is to be fact-driven always, right? And all those things. If you are able to understand all these things, that means you become a supporter of the Six Sigma ideology, and now you can be a leader in your organization. Otherwise, definitely not, right? So that is the white belt. But white belt, qualifying as a white belt is not sufficient enough to work in the project. To work in the project, you must graduate to the next level. Immediate next level is yellow belt. Yellow belts are like the nurses in the hospital, right? The nurses work under the guidance of the doctor. Similarly, yellow belt will always work under the guidance of the green belt only. They can't work on their own. So in order to move up, you have to graduate to the next level, which is called a green belt. Now, as a green belt, you can be a project team member, or you can also lead projects. But again, there will be a limitation. What kind of limitation it is? Certain projects you can deal, but not all the projects. As an MBBS doctor, you can deal certain cases, but not every case, right? There are specialists available, right? Same way, for complex problems, black belts are required, right? A problem becomes complex if multiple departments are involved in the issue. And in such cases, certain high-end statistical tools needs to be involved for validation and analysis. And so a black belt is required. And generally a green belt is, I would say, 1 out of 100. 1 out of 100 will be the ratio for green belt in any company which believes in Six Sigma. And for black belt, it will be 1 out of 200. And it's not the end. You can still go ahead in the ladder and become a master black belt. So it is the master black belt who will mentor the black belts, mentor the green belts to drive, to run projects in line with the organization's preference. It is very important. Any project supported by the organization is in true alignment with the strategic goals of the company. And this strategic alignment, certain tools like ocean planning, we'll be discussing with you at the master black belt level. We do 1 batch in every 6 months. And there will be only 15 participants, where each participant will be learning the modules by directly working in a project, right? And that's the master black belt. It is the master black belt who will train the black belts and green belts for the company and create the belt holders. And not only that, it is the master black belt who will develop the KPIs for the whole organization, for all the departments, at all levels. And of course, a few more roles are required for the success of a project. These are called champions and sponsors. Who is the sponsor? The person who has the authority to approve a project. The person who has the authority to provide resources to run a project. He is called a project sponsor, and this is not a qualification. This is a title, and he may be a yellow belt or a green belt, or he can be a black belt. He can be anyone, but he should believe in the Six Sigma ideology and all this stuff. And he is called the project sponsor. And there will be one more role called a project champion. He will liaison between the sponsor and the project team. He will make sure the approved resources are provided to the team on time. Whenever there is a roadblock the team is facing, immediately the champion will come into picture and then remove the roadblock. Thereby, team will make progress as per the plan and meet the targets as per the timeline. So this kind of infrastructure is absolutely essential for driving Six Sigma projects in any company. I think, okay. So there is a few questions for you people to answer. And what could be the answer here? Who is known as the father of Six Sigma?
Bill Smith.
Yes, it is Bill Smith, right? And then Six Sigma methodology has how many phases?
5.
5 phases. Number of steps? 15.
15.
Define, measure,
Yeah, at the time of introduction, it
Gotcha.
had only 4 phases, but as of now, it is 5 phases.
5.
An yellow belt can lead Six Sigma projects. Is it true or false?
No, false, false.
No,
A
sir.
green belt can lead Six Sigma projects.
In some cases he can, and then in some cases he
Yes.
has
Can
to
be a
take
team
guidance.
member.
It is true. It can be a team member. He can also lead projects, but only simple projects. The limitation is project becomes complex, then it becomes a candidate for black belt.
Yeah.
What is the focus of lean? Is it reducing waste or reducing defects or reducing variation?
Reducing
Reducing
waste.
defect.
Reduce defects.
Yeah. What is a waste? Non-value adding activities.
Generally,
And focus of Six Sigma is to, what is the focus?
Reduce defects.
Reduce defects.
Very good. And now we need to integrate both lean as well as Six Sigma because it can produce breakthrough result. Like RK was saying in the morning, organization need improvement in results and not just normal improvement, a breakthrough improvement. If you talk to any top management, their expectations are always high, and you will be able to meet their expectation if you drive lean and Six Sigma together. See here, the Six Sigma, it reduces the defects by reducing variation. Lean eliminates the waste by reducing non-value adding activity. The justification, the benchmark target is 3.4 DPMO for Six Sigma, and the justification for lean is your process will get accelerated, right? And Six Sigma will lead to savings in cost of poor quality. Lean will lead to reduction of operational cost. Your cash flow will become very smooth, right? And then learning curve is long as far as the Six Sigma projects are concerned, but learning curves are short as far as the lean projects are concerned. That reflects in the project duration also. Generally, Six Sigma project require 2 to 6 months of time. Lean projects you can complete even in a matter of 1 week to 3 months. And Six Sigma is data driven. Lean is demand driven, right? Six Sigma solves highly complex projects. However, lean solves simple and moderate projects. In short, Six Sigma improves the effectiveness of the process. Lean improves the efficiency of the process. And financially, both this approach when integrated, it can give you growth in top line as well as in bottom line. Bottom line is making your cash flow smooth, making your profits maximized. And top line is maximizing your revenue. And both are possible. And it depends on the kind of projects, right? So this is the roadmap for excellence for any organization. I'm just suggesting, see here, the same thing I already told you, 1.0, 2.0, 3.0, and 4.0. If you really wanted to crack your market segment, see here, you have to continuously work on improving the Sigma level of critical processes, not all the processes, at least critical processes, the Sigma level has to be continuously improved. If you improve the Sigma level, look at the DPMO, gradually decreases. And see here, increase in Sigma level requires exponential defect reduction, right? But how do you reduce defects? Initially, it is easier. You use logic and common sense to solve certain problems solved. Your ideology is just 1.0. Just common sense, some logic-based approaches. You follow any methodology, you will be able to solve certain problem. But after some point of time, you have to be systematic. Like you will start using quality control tools, start using project management tools, and educate your people. And that means you have come to the second level of maturity. And now your Sigma level can slightly improve. And knowingly, unknowingly, all companies they have process, they have Sigma level. Only thing is they don't know about it, right? They use a different terminology. That's the difference, right? And Six Sigma is not something very new. Somehow we use different terminology. That's the difference. And now once you solve certain problems and go up in the market, and a time comes where the company wanted to really scale up the business. A time comes where the company really want to scale up the business. For example, no, we operate today only in Chennai, and now I wanted to spread across the country. If I spread across the country, then I would like to know make my actually the products and services available across the globe. That means I wanted to scale up. When I want to scale up, it simply means I wanted to serve a huge lot of customers. When you really want to serve a huge lot of customers, and tell me what should be the tolerable defect level. It should be completely defect free, isn't it? Otherwise, what will happen? You will get money, but you can't even sleep for a minute. Every single minute there will be a complaint. Every single minute somebody will be filing a case against your company, and all those nonsense things will start happening. So no company can escape from producing defect-free products, or adopting Six Sigma when they come to the level of scaling up the business. Otherwise, they will end up, they will stop their journey somewhere here. They will be settling with the just, enjoying the low-hanging fruits in the tree. They'll never be able to grab a major portion of the market. But companies practicing Six Sigma, they know the importance of, producing defective products. So they will adopt the DMAC or DMAT methodology and make sure all the existing problems are solved. Now the processes started producing defect-free outputs, and that's the best time to scale up. And now that you have become a big brand like Apple, and now every product that is coming out of the brand is considered a world-class product. That means now the methodology is DMAT-V, designed for Six Sigma. They just see the logo and then trust the complete product. If the logo is there, they will buy. You know why? Because their approach is designed for Six Sigma quality. And the methodology used in product development is DMAT-V, define, measure, analyze, then only you design. Then you verify, repeat the cycle till the product design and the features meets the customer expectation. So this is what is, the roadmap for excellence. And see here, the starting point can be easily achieved with the simple lean tools like Fivers, Kaizen, and all those things. But when you really go up in the market ladder, you have to equip your people on DMAC and other things. And ultimately, we have come to the last slide, session recap. So what is operational excellence? Operational excellence means you should be able to execute the strategy consistently and reliably better than your competitor, right? And then quality is meeting customer requirements consistently. KPI, key performance indicator, nothing but a number, but this number differs from metric. You know why? KPIs helps us to understand whether we are progressing towards the goal or not. If the number is not revealing that, then it is just a metric. If the number is helping you to understand how you are progressing towards the goal, then the number is called KPI. Every KPI is a metric, but not every metric is a KPI, right? And then quality is a function of 4 activities we do. What are the 4 activities? Our ability to understand customer requirement, our ability to design products meeting the customer requirement, and our ability to develop capable processes, and our ability to take care of the employee requirement. Take care of these 4 requirements, quality is taken care, right? Eliminate waste using lean and prevent defects using Six Sigma. Of course, you can use them for corrective activities also. And Lean Six Sigma as operational excellence model will improve the quality, reduce the cost, and as well as the lead time to delivery. And these are the lean tools, and which you will be learning one by one. And Six Sigma as such do not have its own tools. It is nothing but an amalgamation of many other tools that are already existing. Like some of them are QC tools, some of them are project management tools, some of them are problem solving, some of them are decision making, and so on. That means a single course you are going to build multiple skills, and thereby you really become a leader in your organization. So use appropriate tools, appropriate methods to correct and prevent the failures. So that's it. And if there are any more questions you're interested in asking at this point of time, I am okay to take your questions. Okay. Sorry, we got delayed.